Good morning, all. Hello. Shall we start? So I have the attendance is very less. Only 21 of you joined. So inform your friends to join the classes. Don't miss the classes. Okay. Okay. In the previous class, we just discussed about the distributed systems, in which we saw that if one computer fails, the other computer will take control of the job where the computer was performed. So in today's class, we'll be dealing about hierarchical systems. So you know the meaning of hierarchy, right? Hierarchy is nothing but the process flow, or how the power flows, or how the control flows. For example, if you are a nuclear family, usually father will be the head of the family. So you will. So if you want anything, means first you will put your quotation to your mother. You want this, please ask father that whether it is his decision to buy, or whether he is in support of that and all. Similar way, the machines also follow some hierarchy. For example, in this diagram, you can see that tasks are divided according to functions. Example, one computer is used for DDC, other is used for supervisor controller. If that is the case, how uh, how the control will be with the uh, decision levels. So you can see a diagram here. You can see a diagram here. In this triangular diagram, you can see the boxes here, small boxes, which are nothing but the decision makers. The decision makers are the one which will take the information from the lower level computers, give the commands to the lower level computers, share the information from the same level computers, and share the constraint from the same level computers. So you can see the arrows there. So each decision maker will have the following information. It will take the information. It will give the commands. Similarly, you can see the three types of structures here. One is top level structure, the intermediate level, the bottom level. So these are the three types by which you can have the control of the computer systems. Each decision element receives commands from the level above and sends the information back to the level. On the basis of the information received from the elements below and from the constraint imposed by the elements at the same level, it sends the command to the elements below and information to the elements of the same. So what I mean to say is, it is just like a hierarchy. For example, take an example of a school. The school is controlled by the principal, which in turn controls the staff. The staff in turn controls the students. So what I mean to say is, you have some certain hierarchy. You should follow. You should obey your teachers. Your teachers should obey your heads. Heads should obey the orders of principals. Likewise. So there is some hierarchy in machines also. So you can see here the decision time scale. Decision time scale is long for top level center. It is short for the bottom level control. So one example is given here. It is a manager. If you want to manufacture anything, any goods, so you need to control a batch using hierarchical system. So you can see here many computers. Here in this example, one, two, three, four. Four computers are connected into a data highway where they can communicate and they can talk to each other, thereby controlling the computer control system as well as supervising the control system, supervising the interface. So what I meant to say here is, uh, by using the concept of hierarchy, we can easily achieve both control application as well as supervisory application by using computers. Okay. So now we have the concept of distributed system. So instead of having connectivity among the systems, you can use for different applications, use different computers. So here in this diagram, we can see a distributed hierarchical system where at the first level, where the measurement or actuation is taking place, you can see in this example, there are three computers performing the measurement. And uh, so I would wish to show you a video on this distributed system. Wait for a while. Excuse me.
Real-time distributed system can be defined as a computer system which generates the system behavior based on the logical result and time when the result is produced. Real-time distributed system are focusing on fixed time, which means time constraint, and it will be interrupted if it did not reach a certain time. Real-time distributed system has been used and implemented in our daily lives. Examples: medical equipment that needed to be a real-time distributed system to monitor the condition of the patient, avionics and aerospace system, automotive electronics and process control system.
First, the reason of why real-time systems is very often implemented as distributed systems is because of fault tolerance. Fault tolerance is the ability of a system to maintain its functionality even in the presence of faults or errors. Fault-tolerant systems attempt to detect and correct latent errors before they become effective. The fundamental requirement from any real-time system is to achieve fault tolerance by using distributed systems. Next is because of certain processing of data must be performed at the location of the sensors and actuators. Sensors control processes that collect information from sensors and may buffer information collected in response to a sensor stimulus, while actuator control processors that generate control signals for actuators. Last, the reason of why real-time systems is very often implemented as distributed systems is because of performance issues. By implementing real-time system as distributed system, it can improve the performance by balancing the load across the nodes of a distributed real-time systems.
There are few characteristics of real-time distributed system. The first one is it is made up of concurrent process of tasks. They have concurrent control of separate system components. Concurrent means the action of transmit and process is happen concurrently. The second one is its support for numerical computation. The term numerical computations refers to the use of computers to solve problems involving real numbers. Distributed system can support computation that may introduce numbers that cannot be represented in the computer. Process share resources. The process share resources such as processor and it communicate to each other. Thus, this makes scheduling a process a central problem. Additionally, it has extreme reliability and safety. The purpose of having extra reliability is to make a system failure free. Meanwhile, the purpose of having extreme safety is to make a system accident free. The last characteristics of real-time distributed system is large and complex. Such systems usually embedded in a larger system like a car, CD player, and a camera.
First of all, real-time distributed systems give immediate responses, which means it offers immediate updating of database and responses to user inquiries. Then, real-time distributed system is important for application where high frequency of changes must be made to file during short time to keep it updated. Last but not least, in the real-time distributed system, only the specific records are affected by transactions and inquiries need to be processed and several databases can be processed and updated concurrently.
What is deadline? Deadline is time constraints are often expressed as deadlines at which processes have to complete their execution. means that any processes need to be completed at the exact time and punctual by the time. Deadlines can be in three states, which is soft, hard, and firm. Processes can be finished after its deadlines, although the value provided by completion may degrade with time. Means that the the quality of the processes may decline by the time. Next is hard deadline. Hard deadline is has to be met strictly. If not, process will be catastrophic by time. Is not used.
Large part in computer industry. Real-time system are right time. Nowadays, real-time distributed systems spend a large part in computer industry. Real-time systems are increasing to many other domains such as automotive industry and embedded real-time system. Especially the growing of the internet with multimedia application has opened several new volume applications today.
Hello, and welcome to the world's best iOS development course. My name is Angela, and I've been working as an iOS developer for over 6 years now. And as a part of my job, I work as the iOS lead at the App Brewery. I also teach on our in.
Hi students, welcome back. Coming to the
Okay. Mm. So you got an idea of distributed systems. So just see here, for every each and every level, you can use a computer, and all the computers are connected to the serial highway. That is the key scheme in distributed systems. So you can see here, this is an example of distributed as well as a hierarchical system. Why? Because at each level, you find the computers following some order. So you can see here at the level one, you can say that the job done by the computer is measurement and actuation. Level 2, it is DDC, that is direct digital control. Level 3 is sequence control. Level 4 is operator communications. And level 5 is supervisory control. So here at this case, level 1, you can see there are 3 microcomputers for our application. So for example, uh, the main theme of this is you can have as many as computers in your plant or a process. So that is the meaning of distributed systems. Uh, Then we have the final topic of today's discussion called as HCI, Human Computer Interface. So after successfully writing the code, setting up the computer, and controlling a plant, the major what to say, the major concern is to develop a HCI, Human Computer Interface. So for example, if you come across any project, um, yeah, the main objective of developing a project is to make life easy. The same type, if you are deploying computers for a control application, then the major task lies in designing the interfaces, human computer interfaces. For example, if you are designing a fire alarm system, you need to provide a touch screen to disable it or to enable it. So nowadays, it is HCIs are basically the touch screens usually. Earlier days we were using switches. Now switches are replaced by touch equipment, touch panels. So you can have an assignment here at this point of time. Just develop a HCI, design, and develop an HCI. HCI stands for Human Computer Interface. So you can submit it in the Google class. Okay, you can submit it in the Google class. Google Classroom, submit the write up as one single page write up is sufficient. uh, you can just contact me if you have any doubts. Okay. With this, if you have any doubts, unmute yourself and answer. You can ask me the doubts. So this completes your module 2. So if you have no doubts, you can mark your attendance and you can leave the class. Thank you. TDC 743. Okay then. If you have doubts, thank you very much. You can leave the classroom. Thank you. TDC 743.